I'm going to show you guys next an organic synthesis reaction that helps us determine, it helps us remember some reactions also. So, what I mean by that is I'm going to start with something, okay? You might say, well, what are you going to start off with, Bilal? Okay, so let's say I'm going to start off with CH2 double bonded to CH2. And I'm going to use purple as my reaction arrows. So the first thing I do is I take that CH2, CH2, and I say I want to add 2 BRs. I'll do skeleton also, but first let's do this foray. So add 2 BRs, and this is reaction number 1. And I'll ask you, hey, do you remember how you can do this? And that's an alkene reaction, if you remember. The way to do this is, and I'm going to write the reagents in white, is that you need Br2 in aqueous or ethanol or gas. And that's it. And that is electrophilic addition reaction. It's electrophilic addition. Okay. Now, in fact, I might move this a little this side, and I'll tell you why later. Then we did another reaction with the same halogenoalkane, and I said reaction number 2 I'll put in. I'll say I'm taking ammonia in ethanol, and you're going to heat in a sealed tube. What you're going to get? So what you're going to get is you're going to eliminate the BRs. Come on. And now you got to eliminate both BRs with what? With NH2s on the left side and the right side. And that's how you write NH2 on the left side. Okay, reaction number 1 we saw it in alkenes. Reaction number 2 we just saw this in halogenoalkanes. All right. Then a reaction that we might not, it's not that important, but let's write it down also. Let's say I tell you that, hey, CH2 can become CH3 and CH3, which is going from an alkene to an alkane. And that reaction, what do you need in reaction number 3? That is just hydrogen and nickel catalyst and heat. And that goes from an alkene to an alkane. Then I tell you that, hey, what if I want to make this? I want to break the double bond and on both sides add an OH. OH on the right side and OH on the left side. And in fact, I might move it a little here because I need some space. So it's CH2OH on the right and CH2OH on the left and right? And I tell you that, Bilal or guys, I can go from the halogenoalkane to this fellow. That's absolutely possible. And I can go from the alkene to this fellow also. Both are possible. And if I were to number them reactions 1, 2, 3, let's call this reaction number 4 and reaction number 5. Reaction number 4 is replacing the bromines with OH ions. OH, right? We've done all these reactions before. Do you remember what this reaction is? Replacing the 2 halogens with the 2 OH. What do you need for that? You need NaOH in aqueous form. So NaOH aqueous, and the conditions are heat under reflux. But I can also go from an alkene to this. We've done that in alkenes. If you remember, that was called the mild oxidation. And for that we need to eat with acidified KMnO4 at room temperature, also known as cold. Cold is fine. Acidified dilute KMnO4. Acidified dilute KMnO4 at room temperature also gets you the diol. Okay, we've seen this reaction. Now another reaction, and I'll do them in green now because there's too much purple now. Now what if reaction number 6? Now reaction number 6 I'm giving you is that if I were to, instead of take Br, I put NaCN in ethanol, what would happen? And the condition is still heat under reflux. In that case, the two Brs are replaced by C triple bond N, C triple bond N. The skeletal for this would be a little funny. C triple bond N, CH2, so it'll be like C, CH2, 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 1, 2, 3, 4. And this 1, 2, 3, 4. And then the left one will bond with the N, the right one with the N, but that's a triple bond like that. Triple bond like that. Now it's not as pretty, but that's what it is. And then a reaction I showed you was a common reaction given after adding the CNs is, let's say, adding dilute H2SO4 and heat. What will that cause? That would cause the CNs to hydrolyze to COOHs. So you end up putting COOH here and COOH here. So you went from a 2-carbon alkene all through different pathways to give you a 4-carbon acid. This is a 4-carbon acid. One, like this, 1, 2, 3, 4. And that is C double bond OOH, and that is C double bond OOH, if you're interested in the skeletals for this. Okay, so this is a good example of, and they can give you the molecules and say, hey, you make the, what you call it, the reagents and conditions, or they'll give you the reagent and condition and they'll make this. So you can either write cold. Cold implies room temperature. So for those who are wondering why I wrote room temperature, when we write cold, it doesn't mean freezer cold, it means room temperature cold. So that's what it is here. And we've done this. So reaction number 1 was electrophilic substitution. Reaction number 2 is nucleophilic substitution. Reaction number 3 is reduction of an alkene to become an alkane. Reaction number 4 is also nucleophilic substitution. Reaction number 5 is oxidation. Reaction number 6 is nucleophilic substitution. And reaction number 7 is hydrolysis. So you have all of that, and then you have all these reactions also. And this, seeing the things like this, seeing reagents like this, seeing molecules like that, which should make it easy when you start remembering this kind of stuff. Okay.